Okay, so everybody take a look at this, please, this function, and I want you to tell me what are the values of A, H, and K. Now think about that for a second, and then why don't you type it in chat for me? What are the values of A, H, and K? Tell you what, let's do them one at a time. So in chat, could you tell me, everybody type in chat, what's the value of A? Good stuff. It's the number out front, isn't it? A is 3, very good. Okay. What's the value of H? And be careful with this one. What's the value of H? Okay, good. Yeah, now I'm seeing a couple different answers. The answer is 5, not -5, right? It's an easy mistake to make. Remember, H is always going to be the opposite of whatever that sign is. It's the number that's being subtracted from X, and +5 is what's being subtracted from X, correct? Okay, so H is 5, K is easy. What's K? Very good, -6. Okay, very good. All right, so now let's do these transformations. But we talked about last week, remember we said that we could follow order of operations, but the transformations relating to A, H, and K are independent. We can do them in any order. And so let's, instead of following order of operations where we have to do the horizontal translation, then dilate, and then vertical translation, that's a little confusing. Instead, why don't we go ahead and just do both translations first and then dilate? Okay. So if H is 5, what does that mean we're doing? What's that telling us? Type it in chat for me. What do I have to do to my parent graph? And the parent graph here, I guess I skipped that. The parent graph in this case is just a plain old absolute value graph. Everybody agree? Okay, I'm going horizontally 5 units. It's +5, so I'm going to the right. Good. So there's my first step, is I'm going to the right by 5. Everybody agree? Okay. What's next? What about K? We went horizontally 5 units to the right. I'm going vertically what? Type it in chat, please. I want to hear from everybody. Okay, good. Down 6. Okay, good. So we go down 6 and we end up right there. Everybody agree? Okay, there's the H and the K part. Now what about the A? Okay, I want you to notice here, we're starting with our parent graph of an absolute value function, which is our V shape, but the V shape is our most basic V shape, the most vanilla V shape we could create, which is one that has a slope of 1 on the right and -1 on the left. In other words, the way we like to think about this, the height of the function, if I start at the vertex, if an ant starts at the vertex and goes 1 to the right, he's going up by 1. If he goes 2 to the right, he goes up by 2, etc. Everybody agree? If he goes 1 to the left, he goes up by 1. Okay, that's our parent graph shape. We're going to dilate this thing, though. A is equal to 3, right? So instead of going 1 to the right and up 1, what are we going to do? If the dilation factor is 3, what do I have to do? Instead of going 1 to the right and up 1, what am I going to do? Okay, I'm stretching by 3. Good. Very good. So I'm going to go 1 to the right, and I'm going to go up by 3 in this case. How come? Because what does the vertical dilation factor do? It multiplies by the normal parent height. Well, normally when we went 1 to the right, we went up by 1. I multiply that by the vertical dilation factor to find out how far my stretched height is going to be, my dilated height. So A times 1, 3 times 1 is 3. So instead of going 1 to the right and up 1, I'm going 1 to the right and up 3. Everybody get that? Okay. So then I've got to take this function and I've got to stretch it up like so. That's pretty tricky, huh? You didn't know Mr. Roy had so many tricks up his sleeves. And that's my answer. Everybody agree? Okay, give me a 1 to 5 on that. Okay, let's try another one. How about this one? So really quick, would you guys please type down the values here of, A equals what, H equals what, K equals what? Type those in chat. Okay, and fill in the blanks. So what are those numbers that go there? Okay, good. Okay, so we all agree A is -2. Okay, what about H? Type the value of H in there for me. And be careful with this one, right? This is the tricky one. If I have an X plus 6 inside the function, what's the value of H? Everybody give me the value of H here. Okay, yeah, this is the tricky one. It's -6, isn't it? Right? This is a tricky one. And how come it's negative? Well, because it's always going to be the opposite of whatever that sign is, right? H is the number that is being subtracted from X. Well, isn't X minus -6 equal to X plus 6? Everybody agree? So the number I would have to subtract from X to get X plus 6, I would have to subtract a -6, right? That's the tricky one. The other two are pretty straightforward, but H is always going to be the opposite of whatever that operation is. If I'm adding a number to X, then H is negative. If I'm subtracting a number from X, then H is positive. Okay. And then finally, K is just -3, isn't it? Okay. So, whoops, let's go back. So then let's do our translation first. Horizontally, I'm going how far in what direction? Type it in chat. Okay. I want to hear from everybody. Okay, left 6, good. So I'm going left 6, and how about vertically? What do I do? Left 6. Vertically, what do I do? Down 3. Okay, good. So down 3. Good, good. There it is. Okay. I haven't dilated it yet, though, right? This is the regular, the plain vanilla absolute value shape. Over 1, up 1, over 2, up 2. So if A is -2, that's my next step. I've got to multiply my normal height of over 1 and up 1 by -2. So now I'm going to go over 1 and down 2 instead, right? So what's that look like? Well, I got to take this thing and I've got to stretch it down, which ends up looking like this is kind of a tricky one to do, but you get the idea here, right? Whoops. Ends up looking kind of like that. Okay, what were the steps? Horizontally translate left 6, vertically I translate down 3, and instead of going over 1 and up 1, I'm going over 1 and up 1 times -2. Over 1 and up -2, which is down 2. Okay, give me a 1 to 5 on that. You getting better? That making more sense? All right. That's pretty good stuff. Okay. Okay, here's an extra tricky one. Extra tricky one this time. A, H, and K. Would everybody agree A is -4/3? Give me thumbs up or a yes. Okay, this is the tricky one. Everybody type in the value for H for me. Think about it. Be careful. What's the value for H? Oh, look at that. You're all correct. Excellent. -1. Very good. H is -1, and everybody knows K is 2, right? That's just the number that's being added outside. So then I'm just going to horizontally translate left by 1, vertically down by 2. Agreed? Okay, but this time A is -4/3, right? So think about this one. I'm going to multiply my normal parent heights now by -4/3. So what would be a convenient parent height to multiply by -4/3? I've got some options here, don't I? I know that if the ant goes 1 to the right, the height is 1. If he goes 2 to the right from the vertex, the height is 2. If he goes 3 to the right, the height is 3. If he goes 4 to the right, the height is 4. Which one of those would be the most convenient to multiply by -4/3? The height of 1, the height of 2, the height of 3, or the height of 4? Which one would be the most convenient number to multiply by -4/3? Yeah, it'd be 3, wouldn't it, right? I want to multiply some number of thirds times 3 so I can cancel the 3 on the bottom. Everybody agree? Wouldn't that be better? Okay, good. So then instead of going right 3 and up 3, I'm going to go right 3 and up 3 times -4/3, right? Well, if I multiply my normal height of 3 times -4/3, look what happens. The 3's cancel, and I just end up getting a -4, right? So I'm going to go right 3 and up -4, which means I go down 4. And so does everybody agree then? What we're going to end up getting is a function that just looks like, let's see, I went 1, 2, yeah, right there, huh? So that's going to be the purple one is going to be my absolute value function. Okay, everybody agree? If I want to play with my fancy toy there, which is fun to do, just go like that, right? I just stretch it down to there. Okay, all good? Okay, last one, and I'm going to let you guys work on this stuff a little bit. So last one here, we're going to work backwards. This time, instead of giving you the function and you producing the graph, I'm going to give you the graph and I want you to write the function down. So really all this amounts to is, same as before, I want to know if I can identify the values of A, H, and K from the graph, then I could just plug those into my template up here. I can plug in the value of A, H, and K because I know A is the number being multiplied outside, H is the number being subtracted from X, and K is the number being added outside, right? Okay, so what are H and K? What's H for this graph? The vertex right there normally starts off at 0, 0, right? So how far was it translated horizontally? 6. Okay, good. So H is 6. Good. How far was it translated vertically? What should K be? Type it in chat. Okay, good. Yeah, 4. It got translated vertically. Now, what about A? Okay, let's look at A. A is a little bit tricky. So I gave you some convenient points on this thing. Here's the vertex, and here's another convenient point that crosses at at the corner of the graph paper, right? So let's look at this now. To get from this point to this point, I went to the right by 4, correct? Now, normally, if I go right by 4 on my parent graph, I should go up how far? Type it in chat. On my normal absolute value parent graph shape, I go right 4 and I go up how far? Yeah, 4, right? Good. I go over 4 and up 4, right? This would be my normal shape, which just gives me that, my regular vanilla V, right? Okay. But what did I do this time? Instead of going up by 4, I went down by 1, 2, 3, 4, 5, 6, 7. So what did I have to multiply my normal height by? That's what A is, right? I'm going to multiply A times 4. A times my normal height has to equal my dilated height of -7. Everybody get that? That's the job of the vertical dilation factor. That's what we multiply by my normal vanilla parent height to get my dilated height, right? Okay, so I'm able to set up an equation then, right? A times 4 equals -7. If I want to solve for A, what's the one thing I have to do? What's the one algebra step that I need to isolate the A to solve for A? Yeah, I just divide both sides by 4, don't I? Right? If I divide each side through by 4, okay, I end up with A equals -7/4. Okay? You can't read that. That's a terrible 7. This darn pen. -7/4. Let's see if that makes sense. So negative makes sense because it got flipped, it got reflected. 7/4. Well, that's a number a little bit bigger than 1, so it should have stretched it a little bit, which is what it did. Okay? That's a pretty tough one. Does everybody get that? How we got the -7/4 there? And it's tough because it's a fraction. It would have been a lot easier if it were just like a 2 or something, -2 or something, right? But I wanted to give you a really challenging one. So give me 1 to 5 on that, everybody. Okay, good. Wow, that's good. Okay, so now you just need to practice this stuff.